Hey everybody, welcome to the episode 2 of the Blueprints to C++ series. Today we're talking about UPROPERTYs, so let's have a look at the outline. So first we are going to cover what are UPROPERTY macro definitions, then go over some basic C++ data types, comparing it to Blueprint data types or showing the equivalent from Blueprint to C++ data types. Then covering what is not supported in Blueprint or which C++ types are not supported, because you can use some types in C++ only, but not make it Blueprint visible or usable. Then we are going over the specifiers and meta tags of UPROPERTYs, talking a bit about some general variables and other topics. And at the end, the tip of the day. So what's a UPROPERTY? UPROPERTY is one of those many macros that define the Unreal C++ game framework, and this allows for specifying in certain ways how variables and later functions and that stuff, how these are shown and can be edited and viewed in blueprints. And also the game framework has a garbage collection system. So like I mentioned in the introduction or in the last episode, that you don't use new, delete, and all these things. You don't use the standard C++ library. When you're programming with C++ and Unreal, the best solution is to use what Unreal offers in its game framework. And so if you use something like UPROPERTY on structs and classes and things, you make sure you define that Unreal is, or Unreal manages all the data, all those variables, functions, and classes, and so on and so forth. So you define a property with UPROPERTY, and then there are specifiers and meta tags that you can define, which we're going through in a couple of seconds. And then you define the variable with the type and the variable name. For example, UPROPERTY, then you have like the specifier EditAnywhere, BlueprintReadOnly, and a category. And you have a meta tag of DisplayName. And if we go back to our project for a sec, like the code from last time, there you can see what we did with the different variables, like we have VisibleAnywhere, BlueprintReadWrite, and so on. And so we are covering all the important parts of the UPROPERTY. But first, let's have a look at Blueprint data types. So what you can see on the right side is like a screenshot from Blueprint Editor when you define a variable in Blueprints. You can see you have the Boolean or the different types like Boolean, byte, integer, float, name, and so on and so forth. And here's like an overview of what the types in C++ are when you are converting from blueprints to C++. And there's some more C++ data types, like unsigned integers of 8, 16, 32, and 64 bytes, and the same with int 16, int 8, int 32, int 64, and we have those floating points. Like I mentioned, it's best to use only that what Unreal and the C++ game framework define, because not also like, or using those types allows it for compilation or cross-platform compilation without any problems. If you're using different types like standard int and so on, it's safer and it's recommended to use this approach. And then we have some types in Blueprint or in C++ that are not supported in Blueprint. This means you can't define a uint16 or int8 or int16 variable or double variable in C++ and make it a UPROPERTY. And I can show you this. Let's go in the in Writer, in the code editor, and let's define a new variable. Let me say, for example, int16, and let's call it test or whatever, and compile it. And then you can see once it's compiled, it says type int16 is not supported by Blueprint. So this means, or that's the good thing about the compiler, it shows you when you define things that are not allowed, especially later on when I show you about private properties that are blueprint, read, write, and read only. We are coming back to that in a second. So these are, like I said, the unsupported C++ types that you can't use, but you can use them inside a class, whatever, but you just can't make them a UPROPERTY. So now comes the fun part, the important things concerning the UPROPERTYs. First, we start with the specifiers. So let's talk about the first 2 points, blueprint read only and blueprint read write. Let's go into code. Let's take speed, what we defined last time. We said it's blueprint read write. So if we go into our project, that's the project that's from last time, we're not really adding new stuff, but we are just using this one as a basis for this episode and the next following episodes to show code and improve on that and add new features down the road. So let's go into the BP cone, which inherits from our cone actor. And if you right click and type in speed, you can see from the cone actor, I can have access to the speed get and set. So I can get it or I can set it. And that's what in code blueprint read write means. If we change this to read only, and let me delete these first and then compile. And if we go back to the code, sometimes just a tip, if you're making changes and you're wondering why those changes are not sometimes showing up, that means you need to close the editor and reopen it to make most changes appear. But let's see if we type in speed, you can see it worked. We only have to get because it's read only. We can only read the speed variable. So this is blueprint read only, blueprint read write. Now some important ones, and you're probably wondering, why do I have to do it? Usually if you're programming or creating a game or using Unreal, you're probably working in a team. And as a programmer defining these functionalities in C++, you can specify what editors can edit, only see during runtime, can edit only the defaults and so on. And this is really important so that you can lay the foundation in C++, and in blueprints, the designers or who work with it can only do what they're allowed to. So what do these from point 3 to 8 mean? VisibleAnywhere, like the name says, this variable is visible in instances and in the blueprint itself. Okay, what do I mean by that? So if we go to the editor and look at our level, if we click the cone, this is an instance, and the details of the instance are specified here. So here you can see the cone actor variables in the instance of that specific cone. And then there is the blueprint itself. If we go see the defaults, we can see here are the defaults of the blueprint that we can edit. So we have the defaults of the blueprint in the details panel, and we have the instance details or variables declared in the details panel of the map itself. So coming back to the slide, so we have VisibleAnywhere. VisibleAnywhere means, like I mentioned, it's visible in the instances and the blueprint. VisibleDefaultsOnly means it's only visible in the blueprints, but not in the instance itself. And the same with VisibleInstanceOnly, it means it's visible in the instance, but not in the blueprint. And visible means you can only see it, but you can't edit it. And that's why there are also these 3 others of EditAnywhere, EditDefaultsOnly, and EditInstanceOnly. And I prepared a small example of this. So let's kind of like go to the code. I copied some lines here, and to show you the differences of these 6 variations. We have VisibleAnywhere, we have VisibleInstanceOnly, we have VisibleDefaultsOnly, EditAnywhere EditInstanceOnly, and EditDefaultsOnly. So let's compile this. Compilation is done. Let's go to the editor. So after compilation, you can see, because we specified it as the cone property category, we can see we have, in our instance, we have VisibleAnywhere and VisibleInstanceOnly, and we have EditAnywhere and EditInstanceOnly. We don't see the defaults only ones that we declared. But if we go to the cone, here you can see we have the anywhere, which is also in the instance, and here are the default only ones. So this is a way to specify sometimes variables, private ones, that you want to see, okay, during runtime, how these values changes and so on. So you can really define what is allowed to see and edit during the instance, or for the instance, and for the blueprint itself. Okay, these are the specifiers. And then we have category, like you've seen from the last time, or what I just mentioned, that you can, let's go in the code, we define a category. It opens like a drop-down panel of its special category where these are placed on. So these are the specifiers. Then there are meta tags. There are a lot more specifiers and tags than I show here. These are the most important ones. These are the specifiers that you need most, and these are the meta tags for properties that you need most. Okay, the first tag is DisplayName. And DisplayName allows you to display the property or the variable name differently than you specified in code. So usually the code name is displayed, but if you are using DisplayName, then you can change it, or it will be shown differently in blueprints. Let me show you this. So if I go to speed, for example, and define a meta tag, meta equals parentheses, and then display name equals, and instead of speed I will say cone speed, and compile. So let's go to the editor, and you can see here this variable speed is now defined as cone speed. And there are several more meta tags that you can use, like Tooltip, which is when you highlight over it, it shows a tooltip. Or for float and integers, you can define the minimum and the maximum values that you're allowed to enter. And AllowPrivateAccess is something that I will show soon. It's about, usually, like I mentioned, that UPROPERTYs that are BlueprintReadWrite or read-only, that they need to be public or protected. You can't have private defined members being a UPROPERTY that is blueprint read write and read only. But this meta tag allows for the private variable to be defined like this. But let me show you just how Tooltip and the min and max work. So let's get back to code and add the tooltips and the ClampMin and ClampMax. Let me just copy this here so that you could see. So of course this parentheses needs to be here. So like you've seen here in the UPROPERTY, you add specifiers one after another with a comma separated. And then the meta tags. You define meta with a small m equals parentheses, and then you have the different meta tags that you want to define, also comma separated. There are combinations that aren't allowed in specifiers, by the way, but this is something that's explained in the documentation, and you can, once you compile and the compiler tells you that, you can find that out. So I'm not going over this right now, but you can see here now we added the tooltip, the speed of the cone, we have ClampMin, and ClampMax. Let's compile this. Oh, and by the way, what I mentioned last time about Writer and why it's so much better in my opinion compared to Visual Studio and so on are the real connection to C++ and to blueprints. I mean, so you can see really here you have two derived blueprint classes, and you can see if you click on it, you can see the cone BP and the cone class from it. And you also see like you have the value speed is set to 80 here, the max value to 250. So it's really neat what you can do. So compilation is done, and let's see what changed. So our cone is still selected, and you can see here our cone speed. If I hover over it, the tooltip appears, and if I, let's say, enter 10, then 20, which we defined as the minimum, is clamped here. And if I go up or use the scrabber, you can only go to 100 or down to 20. And if I type 120, it clamps to 100. So this is a really neat thing to define variables that can only be entered in a certain range, define tooltips for the designers and stuff. So this is a really interesting thing. So about the allow private access, let me show you what this means. If we, let's move this public, let's say over here, we have this val edit defaults as BlueprintReadWrite. If I define this as private and compile, then you can see the compiler mentioned that BlueprintReadWrite should not be used on private members. But most of the time you want to define your members private or sometimes protected, but protected is allowed, but not private. But to overcome this and keep your members private and still be able to define them as BlueprintReadWrite or read-only, we can add a meta tag, allow private access to true, compile this, and then you can see the build succeeded. So this is a way for you to allow private members to be defined as BlueprintReadWrite or BlueprintReadOnly. So we're almost coming to the end. Just some general topics or about variables definition. Like I mentioned last time, but want to recap here, the Unreal convention of defining variables and functions and so on is based on the camel case naming convention. So variables must begin with uppercase, and each consecutive word has starts with an uppercase character. The exceptions are booleans. They start with a lowercase b, like what we defined in the code with bool b is up. Then what I mentioned or just shown, that blueprint read only and blueprint read write definitions work only with public protected members unless you use the allow private access meta tag on private members. And then something that about shadowed variables, they are not allowed in the game framework here, and you will have compiler errors that show you that shadowing is not allowed. That means like declaring a variable in a certain scope that has the same name as a variable that is declared in an outer scope. And this especially, we are going to cover this next episode when we cover U functions, that you can have some naming conventions like in-out naming. But just this as something that I wanted to mention but is covered next episode. So, and here you have the documentation link to the properties, and then about the specifiers and meta tags and so on. I will put the link down in description so you can really access them easier. So now the tip of the day, which I want to make a habit of every episode. And this is about this episode is category and subcategories. Usually what we've seen is you can define a category and give it a name, and then you see like in the details panel your category appearing, and the variables that you define there are in this category. But what if you want to make a hierarchy that you say, for example, like in this we have like a config category, like a top category, and we want to define subcategories that specify, like what I here say, the bounds, the startup values, or whatever you want to do. So what you usually do is you define the category, config is the top category, then you use the pipe symbol with the subcategory underneath, or the subcategory coming after it. Then you can use actually another pipe symbol to make a real hierarchy out of these categories and subcategories. So let us do this as a last example here with these four, or these visible and edit anywhere variables that we defined. So this is visible anywhere. Let's say we have cone property test anywhere, and I copy this and say like here, then we have this as visible, or instance, of course, not visible, and this is instance, and this one is default, and I think I'm missing one. Let's get rid of this for now, and the meta tag, and define this as default as well. So if we compile and go back to the editor, you can see here that now we have subcategories. Anywhere an instance in this one, and if we open the BP cone, wrong monitor, and we have these categories here. So I think that's it for today. So thank you very much for watching. Hope you enjoyed this new episode, and a lot more episodes are coming. And so if you want to get notified when new videos are coming out, then please subscribe to the channel, and like and subscribe would be great. Thanks a lot, and see you next time.